Chapter 1, we will be discussing just introduction to statistics, vocabulary and terminology, and so forth. In 1.1, we'll be looking at some basic definitions that are necessary. All right, so data is the information that we're collecting. It's coming from observations. Maybe we're doing a survey, we're counting things, we're measuring things, or we're collecting responses to a question. For example, people who eat 3 daily servings of whole grains have been shown to reduce their risk of stroke by 37%. Someone actually did some kind of survey and asked people what they ate. 70% of the 1,500 U.S. spinal cord injuries to minors resulted from vehicle accidents, and 68% were not wearing a seatbelt. Again, somehow or other, some observations were made, some counts were done, and responses were taken. Now in statistics, it's the science of collecting, either through surveys or through measurements, organizing into possibly tables or into graphs, analyzing into, for example, measures of central tendency or the amount of variability in a data set, and then using that data in order to make some kind of decision. The population is the collection of the all. The key word here is all outcomes of interest. Now, if we're interested in the average cholesterol of an adult male between 50 and 60, the population is all adult males between 50 and 60. If we were only interested in, though, if I'm interested in the average GPA of the students in my online class, then the population is just my students. If I'm interested in the average GPA of online students at Florida Southern, then it's all the online students at Florida Southern. The sample is a subset from this same population. So everybody in your sample, or every observation in your sample, comes from that population of interest. For example, if we took a survey and 1,500 adults in the United States were asked if they thought there was solid evidence for global warming, 855 of the adults said yes. Identify the population and the sample. So if we surveyed 1,500 adults, then the adults in the U.S. would be the population, that's the all, and the 1,500 adults that we actually surveyed are our sample, right? So the response of all U.S. adults and the response of the adults to the survey. So the population consists of responses of all adults in the U.S. The sample consists of the 1,500 adults in the U.S. who answered our survey. As the sample, you notice, is a subset here, a subset of the larger population of U.S. adults. Now the data consisted of 855 yeses and 655 noes, but that's the data set. That's not the population or the sample. A parameter is a number that describes a population characteristic, the average age of all people in the United States, versus a statistic, which is a number that describes a sample characteristic, the average age of people from a sample of 3 states. Notice the parameter is the value that we're interested in from the population. The statistic is the value that came from the sample. Now decide whether the following is a population parameter or a sample statistic. A recent survey of a sample, that's a key word there, of college career centers reported that the average salary for petroleum engineers is $83,121. Since this came from a sample, it must be a statistic. 2,182 students who accepted admission to Northwestern in 2009 have an average SAT of 14 42. Now this is all of the students who accepted admission offers to Northwestern. So this must be a parameter. We have two types of statistics. Descriptive statistics, which is dealing with the data itself. It involves the organizing into tables or into graphs, summarizing data into measures of central tendency or measures of variation, and displaying the data in some form. Descriptive statistics is more interested in the data itself. Inferential statistics uses the sample data, but it's really about drawing conclusions, or in other words, making inferences about a population. So here we have a sample, a study that was done, and part of it is from the branch of descriptive statistics and part of it is from the branch of inferential statistics. A large sample of men aged 48 were studied for 18 years. For unmarried men, approximately 70% were alive at age 65, but 90% were alive at age 65 if they were married. Okay, now, the descriptive statistics are those numbers. 70% of the unmarried men were alive at age 65. Married men, 90% were alive at 65. That's the descriptive statistics. That's the part of the study that dealt with the numbers and the data. Now, an inference was probably made from this study, and the possible inference might be that married men live longer. So this ends section 1.1. We have defined statistics. You should be able to distinguish between a population and a sample. You should be able to distinguish between a parameter and a statistic, and you should be able to distinguish between descriptive statistics and inferential statistics. Please stop now. Go to www.coursecompass.com, which is the My Math Lab website, and open up homework for section 1.1 and do those problems before you continue on to section 1.2. Thank you.